Hello everybody, my name is Walter and this is episode 4 of my Redstone Whistle-Blowing Series. In the previous 2 episodes I talked about my realistic bunk elevator, first about the basic functionality of an elevator that goes up a floor or down a floor, and then I added a call function, and now we get to the final increment, which is a level select function or remote call function. So first let's talk or show you what this is. Well, let's actually go to not the topmost floor, since the remote call is not implemented on the topmost floor. But if we go down here, you can see instead of the 2 buttons I had in the previous versions, I now have a lectern and a single button. And this lectern is basically used to select a floor, and then you press the button, and the elevator then will go to that very floor. And you can actually activate it from the inside, which makes sense. So let's go down to floor 2. Activate it. Now we need to wait a few moments. And now we get transported down. And at some point we will arrive and can get out. So that's the level select function. And here I showed you just the example with going 1 floor down, but obviously, as you can see, you can select any of the other floors. So let's send it up back to the topmost floor while I'm talking. And that's what I want to talk about today. Now, as you can see, the circuitry is fused to the other side, opposing the circuitry that's required for the call function. And since the whole thing is a bit hard to see in situ, I copied it over there to explain a bit more in detail what goes on there. Now, before I actually go to this implementation here, as you can see, the elevator has now arrived. Now, before I actually get into the actual implementation, I will go into a little PowerPoint presentation I prepared similar to the previous episodes, where I want to show you how the circuitry is supposed to work, so you have a bit of a better idea of what's going on. Again, the colors I'm using for the wool blocks here are pretty much the same as the colors for the connections in the schematic of the circuitry. And with that, let's make a quick jump over to PowerPoint. And here we go. Now, if you haven't watched the previous 2 episodes, I would really recommend doing so, or you will most likely get confused in the following. Anyway, let's continue. So what were my thoughts about how a level select function could be implemented for this elevator here? Well, I quickly figured out that I already have something very similar. I have the call function, which allows me to call the elevator to my current floor while it ignores all of the intermediate floors. For a level select, I need to do something very similar, just with another floor. So I decided to go with a remote call, basically remotely triggering the call function on the target floor. Another thing I needed to address were the inputs. Up to this point I had 2 buttons, one to go up a floor, one to go down a floor. But now I can or need to address more than just those 2 floors. Subsequently, I went with a combination of an analog input and a button. In this case, I used a lectern, which allows me to address up to 15 floors. I could also have gone with an item frame that would have limited me to 8 target floors. And those obviously now replace the up and down buttons, which are no longer needed. Then I needed to consider how do I want to connect the 2 different floors. Here I decided to go with 2 signal lines, which should be bidirectional. One sends a pulse for the remote call start, and the other sends a pulse for remote call end. The actual level selection happens via the delay between those 2 pulses. So each floor basically has programs in a certain delay, and if the pulses arrive at that specific delay or with that specific delay in between, then a call on this floor is triggered. This is basically a variation of a pulse length modulation. If you want to know more about this, I explain it a bit more in my Redstone Circuits episode 9. Subsequently, since I'm going with this setup and I want the call to be as fast as possible, and there are already some delays involved due to me needing to have a delay for the actual selection, I decided to go with a variation of the piston slime block redstone block tower that adds just some observers to the mix, and allows me to basically instantaneously transmit negative pulses, and the bus system or the signal lines automatically reset themselves. So I have a bit of a dead time where I can't send a second pulse, but after that I can just send a pulse and everything is working with constant delay. So that's the reason I went with the setup here. Now, when can I trigger such a remote call? When does it make sense to trigger a remote call? Well, it's basically the same as before. A remote call can only be triggered when the elevator is on the current floor. Before, in episode 1 and 2, I could only go up or down a layer if the elevator was actually on this very floor. So it's pretty much the same idea here. So in other words, if the elevator is on the current floor, I'm triggering a remote call. If the elevator is not on the current floor, I'm triggering a normal call. And with that, let's have a quick look at the circuitry for the call function from the previous episode. In here, there are 3 parts that are of interest for us when we are talking about the implementation of a remote call function. The first are those 2 internal buses here, which can, among other things, trigger a call. Then we have the feedback, which tells us if the elevator is idling on this floor with the doors open. And then finally, we have the 2 buttons here, which now need to be removed. From this point on, there is no way to directly trigger the send up or send down bus. At all times, we are only triggering calls, either locally or remotely. Now with that out of the way, let's talk about the interaction between the call and the remote call. So let's start with the simple situation. The elevator is not on this floor. If the elevator is not on this floor and we press the button, we want to make a call. So this is pretty straightforward. We trigger the call function, and we don't even need to check whether the elevator is idling on a different floor, because that check is already implemented in the call function itself. So we don't need to double up here. Now that was the simple case. Let's talk about the actual remote call. So the elevator is idling on this floor. If we now press the button, we trigger a pulse. That pulse travels without delay through our remote call start signal lines, and after a variable delay through our remote call stop signal lines. Those signal lines here obviously interconnect all floors. I just simplified it here and represented it with the big arrows here. Now on this transmitting side, there is one more addition you can make, and that is some spam proofing. So what the circuit here would do is it detects, okay, the remote call has started. And until the end of the remote call, the button is disconnected from this remote call function. Now, this is completely optional and didn't really make it into the final cut of my circuitry due to space requirements. But this is just an optional spam proving, so it doesn't interact or doesn't affect the actual circuitry itself. So that's the transmitting side. Now let's talk about the receiving side. What happens if you receive a remote call? Now we simply need to decode this, and the simplest way you can see here. So this time we delay the start pulse. And if the delay for the stop pulse on the transmitting side and the delay on the receiving side for the start pulse are the same, then the 2 pulses will overlap in this AND gate here and then trigger a call on this floor here. Or at least try to trigger a call on this floor. If the delays are different and the pulses don't overlap sufficiently, then nothing will happen on this floor. That's how I encode and decode a remote call. Now there is still the analog side of this whole thing missing. And that is basically, how do I set those delays? On the receiving side, it's pretty simple. I only need a constant analog signal to set this to a specific floor, or to program the floor so it knows which floor it is actually. Now, the way I'm doing this in the circuitry is pretty simple, just a container with a certain filling level and a comparator. You will see this in a few moments. On the transmitting side, it's a bit more complex. And the reason for that is a lectern will give me an output between 1 and 15. But one of those actually represents the floor I'm currently on. So I'm basically wasting a whole page. And what the circuit here does is, it broadens the range from 1 to 15 to 0 to 15 and makes a jump at the current floor, or the signal strength that represents the current floor. So I'm not addressing or not able to address the current floor for a remote call, which wouldn't make any sense at all. And the way the circuitry works is pretty simple. First, we check whether we are addressing a floor above us or below us. If we are addressing a floor above us, we are just connecting the lectern to the delay. But if we are addressing a floor below us, we are subtracting 1 from this signal strength and then putting this into our delay. That's how I get this jump at my current floor level. And that's how I can make it possible for this elevator to work with 16 floors and not 15 floors. And finally, let's have a quick look at the interconnection of those floors here. So those are the two actual bus systems. Since the signal lines are one directional, here I have 2 signal lines per bus system. And as you can see here, it doesn't really matter that much whether I get a feedback from the current system into the current system due to the way I'm decoding, and also due to the fact that I'm jumping over the delay for the current floor. So here I don't really have to worry too much about having a feedback from the current system into the current system, contrarily to how it was in the call function. And that's the circuitry explained, and with that, let's quickly jump over to the actual implementation. Now, to make following a bit easier, I will go through this in a similar order as I did before with the schematics. So let's start with the idle line, which is the blue connections down here. The idle line is connected or controlled by this redstone wire here, which is powered when the door is closed and depowered when the door is open. Subsequently, when this piston is extended, I'm in a call mode. When it's retracted, I'm in a remote call mode. Let's start with the call mode. So in the call mode, this repeater here is powered. And if I now press the button, you can see the piston here extends and connects this repeater to this redstone wire here, which then gets powered, obviously. This is then connected to the internal bus at the back there and will trigger a call on the local floor. The way the signal travels is pretty simple. It basically goes through this double inversion here along this path, powers this block, and that already powers via quasi-connectivity this piston down there. And that's it. Now for the remote call. Here, let's start with showing you this in action. So I press the button, and after some time, first this, then this connection will trigger, and down here it's first this and then this here, obviously. The reason those two only retract for a short amount of time has to do with the way I set this up. So let's disconnect this one here for now. You can see you get this back and forth action. The reason is the piston retracts, observer powers, and the piston extends again. And since it's officially not one-ticked, it goes back and forth. So I have as fast a reset as possible, and the circuitry here will only retract for or depower the piston involved for 2 ticks. Subsequently, I get just 1 pump action, and that's it. And that's what I want. I want an instantaneous transmission along the entire bus. 1 pump, which is the fastest possible reset, and after that it's in the original state again. So that's why I'm going with this very short pulse. So anyway, how does the signal travel? First of all, I get my analog signal through from the lectern, travels through this line of comparators and ends in this comparator. As long as the piston of the button is not pressed, the comparator here is set to 0 as an output. If I press the button, the analog signal now can travel through and ends up in this block, independent of from which side it comes. Here, it will power the block or the redstone wire below, which powers this piston here. Once the button deactivates, the piston retracts again, I get a 2-tick pulse into this torch here, which will give me the single pump of the remote call start. So that's the non-delayed part, more or less non-delayed. There are some delays involved, but they are all constant. Now for the more interesting part. So the analog signal travels into this block here. And then travels along this line here into this comparator clock here. If the selected floor is below my current floor, through this comparator here, this piston will extend, or will remain extended. Subsequently, this composter, which produces a signal strength of 1, will be subtracted from the signal strength. If the signal strength I'm inputting is higher, the piston here will retract, and I'm just using the unchanged signal strength. The reason for this additional line at the top here is because now I have the option to have a signal strength of 0 I need to detect. And a signal strength of 0 wouldn't be able to do anything here. Subsequently, I need that one additional trigger for this system here. This is basically just there to also decode or encode a signal strength of 0. Once the signal has decayed, the piston here will retract, and I get a pulse traveling through the system here in delayed once, turned into a 2-tick pulse, and then sent onto the bus. That's the transmission side. As you can see, there is no spam proving here, which I didn't really manage to fit in here properly, but as I said, it's not really that necessary to the function of the entire system. Basically, this would just suppress the option to press the buttons 2 times, but as you can see, all that happens is basically that you may have a double pump on one side and a single pump on the other. Now this could potentially lead to several different floors being activated at the same time, but that's just a multi-call situation and that's already handled in the call function. Now let's go to the decoding part. So here, let's start with the stop signal. So the stop signal is triggered through either of those observers. Either they are moved down by 1 block or they are moved up by 1 block, depending on which line is actually triggered. In either case, they will trigger those repeaters here. Those repeaters then will run into this first input of this somewhat unconventional AND gate here. The start pulse will either be triggered by this observer being moved down, or this observer be moved up and triggering via this line block, this redstone wire. This then, for a short amount of time, triggers this piston here. This piston will then extend and connect this comparator clock to this analog signal level indicator. Subsequently, this one here is set, and this piston here will extend. Once the signal has decayed, the piston will retract. So this is the part where we have the signals or the level dependent delay. Once the piston retracts, the observer here will power the block, which triggers the repeater at the back there, and which then triggers the second input of the AND gate here. If both of those pulses here end up in the AND gate at the same time, the torch here will activate the repeater, and the repeater runs into our internal buses, which now trigger the call on this floor. And that's already the entire circuitry for the normal stations explained. Now let's quickly go through the bottom and topmost station. So the bottommost station works pretty much exactly the same. Major difference is now there's no floor below, so you don't need the signals to be sent down. And the circuitry of the floors is also slightly different set up, but the functionality is exactly the same. A bit more interesting is the topmost floor. Here, I wasn't able to have a lectern in there because I wanted to leave the topmost floor completely flat, and there was no good way to get that working. So I decided to have the topmost floor pretty much unchanged. So if you press the buttons, you are sent to the next floor below, where then you can make a direct level select. Nevertheless, I have at least the receiving component in there, so mostly or constantly delayed part for the stop pulse and the programmable delay for the start pulse. Again, this runs into an AND gate and triggers the circuitry. So as you can see, the topmost floor is much simpler than the other floors due to the limited functionality there. And with that, we have reached the end of this episode about the final development stage of my realistic bunker elevator. I hope you enjoyed this episode, and well, see ya!